Okay, this is the video lesson for Algebra 2, 8.5, adding and subtracting rational expressions. So we've learned how to simplify rational expressions. Actually, it's a review from Algebra 1. We have multiplied and divided, and now we are going to add and subtract. So adding and subtracting is a little harder. Remember with fractions, when you add or subtract fractions, say we're adding this, right? You can't add them unless you have the same denominator, right? So you find the least common multiple, the LCM, of both, right? This would be 2 times 2 makes up 4, and this is 2. So your least common multiple would be, you need to have at least two 2's, and then since there's one here, that would be 4. So then we're going to make this a 2, and we have to multiply the top by 2 as well to make this 3 over 4 plus 2 over 4. Now the denominators are the same, and we just add across with the same denominator. So we're doing that same exact thing. If you understand this, we're doing the same exact thing, but now instead of numbers, we have polynomials and algebraic expressions. Just so exciting. Okay, so moving on to actual algebra. Okay, so the first thing we're going to do then is practice finding the least common multiple of polynomials. So you just need to make sure that every single factor is represented in your least common multiple. So we want to do kind of like a factor tree here. So factor your 12. This is a 2, 6, which is a 2 and a 3. We have 2 x's, 1 y, and then this factors multiplies to 1, adds to 2, so 1 and 1. So this factors to be x plus 1, x plus 1. So our factor tree, I'm even going to do like x times x, 3 times 2 times 2. So these are all the factors of this here. Okay. And then all the factors of this one, right? This is 2 and 9, which is 3 and 3. So this is 2 times 3 times 3, 1x, 3 y's. And then this factors two numbers that multiply to 4 and add to 5, or 4 and 1. This is x plus 4 and x plus 1. So when we do the least common multiple, you basically have to have every single factor represented in both. So if you just take the first one, and then include everything in that, 2 times 2 times 3 times x times y, x plus 1 times x plus 1. Then we're going to see which ones of these match. So we already have a 2. We already have 1, 3. We need a second 3, so we're going to multiply this by 3. We have an x. We have 1 y. We're going to need 2 y's, 2 more y's. We don't have an x plus 4, so we need an x plus 4, and we have an x plus 1. So we don't need to repeat that, right? So this is our least common multiple. So let's multiply these together. 2 times 2 times 3 times 3 is 9 times 4, which is 36. We have 1, 2 x's. Yeah, x squared. We have 1, 2, 3 y's. We have 2 x plus 1's and an x plus 4. So that is our least common multiple. These are not going to be all that hard, right, when we're doing the adding and subtracting, but this is an extreme example of finding the least common multiple of two polynomials. So here, and you can even see these ones are a little bit easier to do. So press pause, try this one on your own, and then come back, check for the solution, and then we'll do this one separate. Okay, so for this one, you just had to pull out the GCF to factor. This one factors like this. The only one that matched was x plus 2. So if you take these two, x plus 2 was already taken, but then if you add an x minus 3, then the x plus 2 is taken. So your least common multiple is here. You don't have to repeat the x plus 2 since it only appears once here. Okay, so now try this one after you press pause, and then check back for the solution. Okay, and then these three just had a factor, and then so I took these two. This one was already here, so then I added an x minus 2. This one had an x minus 2 already, so I added one more x minus 2. So this is our least common multiple. Okay, hopefully you're catching on to that. So now, with that in mind, we're going to start adding rational expressions. So what we have to do is find the least common multiple of the two denominators, which we call least common denominator. So the first thing we need to do is make these denominators the same, and then we can add them. And then we have to simplify them, and then we're going to state restrictions, right? We still can't divide by 0. Okay, so let's look for the least common denominator here. So it's factor. This one's factored, so just x minus 1 is fine. This one, we need to find two numbers that multiply to 2 and add to -3. So -2 and -1. So this becomes x minus 2 and x minus 1. Since we already have an x minus 1 in the least common denominator, we just need to multiply by -2. So that's our least common denominator, x minus 1 times x minus 2. So let's rewrite our problem. X over x minus 1 plus 2x minus 1 over, with its factored form, x minus 2 times x minus 1. Now, this one, we need both denominators to be this. This one already is. This one needs to be multiplied by x minus 2 to match the least common denominator, right? Which means we have to also do that on the top, right? So that in essence, we are multiplying by 1, which keeps the number the same, right? So let's do that, and let's write this. So then, I always do that, don't I? X times x minus 2 plus 2x minus 1, excuse me, on top. And then the bottom is just our x minus 2 times x minus 1. Right, we just add the 2 and keep the same denominator. And so then we can simplify this, x squared minus 2x, and then plus 2x minus 1 over x minus 2 times x minus 1. And then these cancel, right? And this becomes x squared minus 1 on top. X minus 2 times x minus 1. Now, look what happened. This is factorable. Don't miss that, right? This is our difference of two squares. This becomes x minus 1 times x plus 1. So we're still simplifying here. X minus 1 times x plus 1 on top. X minus 2 times x minus 1 on the bottom. You can see that that x minus 1 is going to cancel, but before we do that, remember you need to state any restrictions. So x cannot be 2 and x cannot be 1. Then we can cancel these two. So the answer is going to be x plus 1 on top, x minus 2 on the bottom, where x is not 2 or 1. And that's our answer. Lots going on. Okay, so press pause here, and then you can try the next problem from your notes. If you want to press pause here while it's still on this screen, or I'm going to switch to the next screen and put it here. So do this one first, and we'll go over it, and then we'll do this one separate. Okay, so press pause, try this on your own. Okay, so here, when you factor this, you'll see this is the LCM is just missing an x here. So do one on the top, one on the bottom. Distribute that, and then subtract 2 on top with this on the bottom. This factors to this, where these are going to cancel, but before that we need to state our restrictions. Okay. All right, so try this one. Press pause and then come back for the solution. Okay, then this one, if you factor it, x minus 2 times x plus 2. So this one needs another x minus 2. Since that's the LCM, do that on the top. X plus x minus 2. Oh, look what I did. That's wrong. Let's go back. See, this should just be 2x. Interesting. Okay, so there was my mistake. Sorry, let's fix it. So this is 2x minus 2 over this here, which then, if you pull out the 2, becomes x minus 1. And then nothing cancels. And so that's your answer. 2 times x minus 1, x minus 2 times x plus 2, and then our restrictions are just x can't be 2 or -2. All right. Moving on. All right, subtracting now. So it's going to be the same thing. You just have to be careful about, right, when you subtract a whole factor, right, you have to distribute the negative. So I'll show you that. Let's find the LCM here. Let's pull out an x. X minus 2. Let's pull out a 2. X minus 2. So our least common denominator is x times x minus 2, and then a 2. So 2x times x minus 2. All right, so this one needs a 2. And that's in parentheses, right? And this one needs an x. So do that on the top in parentheses. All right, so let's rewrite this. This becomes 2 times x plus 2 on the top of that fraction, divided by 2x times x minus 2. That's this here. And then minus x times x plus 2, divided by 2x x minus 2. Right, don't forget this x I added there. Okay, so now the denominators are the same. So let's do the tops. 2 times x plus 2 minus x times x plus 2 is the top, and then the bottom is just the same denominator, 2x, x plus 2. Okay, now let's just simplify the top. So 2x, oops, and then 2 times 2 is 4, plus 4, and then minus x times x is minus x squared, and then minus 2x, all over this 2x, x plus 2. Okay, so 2x minus 2x cancels, and this is, let's pull out a negative and make this x squared minus 4. And then this factors to negative x plus 2, x minus 2, 2x, x plus 2. So before we cancel those x plus 2's, x cannot be 0, and x cannot be negative 2. Can't really write that. Let me move this up. There we go. Okay, so let's rewrite this now. Oh, and then let's cancel. Our x plus, oh, this is x cannot equal negative 2. So these guys cancel. The top becomes negative x minus 2 over 2x. And x cannot be 0 or negative 2. So that's our answer. You could also then distribute this negative back if you wanted to make the answer 2 minus x over 2x. Either one works. Either one is simplified. Okay, so time to try this one. So press pause, try this one on your own, and then check back for the solution. Okay, so once you factor this, you realize you need x minus 1 on this side, and then once you multiply that all out and then simplify, that factors to this, and then this bottom stays there, and then these cancel, but not before you find the restrictions. Okay, so now try this one, press pause, and then check back for the solution, and then we'll be done. Let me move it there. Okay. Okay, so this one, this gets factored to 5 and 1. So this needs an x plus 1. And then when you multiply this all out and subtract the x and the 3, this becomes x squared minus 1, right? This trinomial does not factor. So this stays there. There's nothing else to do there. These are your restrictions, and there's your answer. Okay, a lot. So lots to practice. Actually, only 5 to practice, but enjoy.